multiple bond means 2 or 3 bonds will be present, is treated as a single electron pair. Attractive forces tend to bring the two atoms close to each other, whereas repulsive forces tend to push them apart to get a maximum overlap. When it is getting maximum overlap, what will happen? The bond will get much stronger. Pi bond is weaker than sigma bond because the extent of overlap is less. That's why pi bond is little bit weaker comparative to sigma bond. Hello everyone, this is Harshita Bhavasar from Vidhyaashram, PU College Temple of Excellence. Today we are starting up session 3 from the chapter Chemical Bonding and Molecular Structure. In the last class, we have discussed about the resonance structures and what are the uses of resonance structures and resonance hybrid, polar character of a covalent bond and Fajans rule. These are the contents we have already discussed in the previous session. In this session, we will discuss about geometry of covalent molecules, VSEPR theory and valence bond theory. Okay. So in the last class we have discussed about the resonance structures. So in this session we will discuss the geometry of covalent bonds because one on each molecule will be having different molecular geometry. So based on the bonds, based on the types of bonds and based on the lone pairs and bond pairs, the geometry will be different. So VSEPR theory, in which you will study about the attractive force and repulsive force. So this is about the valence bond theory. Completely you will study in this session. First we'll discuss geometry of covalent molecules and VSEPR theory. So Lewis-Langmuir concept of a covalent bond could not explain the geometry of molecules. Means before session what we discussed, that is Lewis structure, and along with that Lewis-Langmuir structures, they could not explain the overall concept of geometry of molecules, but only they discussed about the valency and valence electrons of molecules and elements. Okay, but Sidwig and Powell put forth valence shell electron pair repulsion theory to explain the geometry of valency. What is VSEPR? Valence shell electron pair repulsion theory. That is to explain the overall geometry of molecules that was put forward by Sidwig and Powell. Next, we'll see now VSEPR theory, that is postulates of VSEPR theory. What they told means the shape of a molecule depend on the number of valence shell electron pairs. Okay, we know what is valency, what is valence shell electrons all. What are valence electrons? The electrons present in the outermost shell of a atom, which will be recognized as valence electron around the central atom. See, if it is carbon dioxide CO means this will be the central atom. Okay, this bond pair or this lone pair should be considered to know the shape of a molecule, not about this one. Okay, pairs of electrons in the valence shell repel one another since their electron clouds are negatively charged. Whatever the electron pairs are present surround the central atom, it will repel because we know that electrons are negatively charged. When the same charges are present, obviously it will repel to each other. That's why the pairs of electrons in the valence shell, it will repel. Since these pairs of electrons tend to occupy such positions in space that minimize repulsion and thus maximize the distance between them. This pair of electron, whatever the present surround the electron that surround the central atom, that will minimize the repulsion and thus maximize the distance between them. Repulsion will be minimized and the distance between them will be maximized. The valence shell is taken as a sphere with the electron pair localizing on the spherical surface at a maximum distance from one another. How they have written means, if anything we have written in with respect to electrons means, within the sphere 2 electrons will be written like that. Next one, a multiple bond is treated as if it is single electron pair and the 2 or 3 electron pair of multiple bond are treated as a single super pair. A multiple bond means 2 or 3 bonds will be present, is treated as a single electron pair. Okay, and later 2 or 3 electron pairs of a multiple bond are treated as a single super pair. First will be considered as single electron pair. Later the pairs of a multiple bond will be recognized as single super pair. Where 2 or more resonance structures can represent a molecule, the VSEPR model is applicable to any structure. If the molecule is having two or more resonance structure, we know that resonance structure, the delocalization of pi electrons will be seen in that. If it is having two or more resonance structures, then also it can represent the VSEPR will be applicable and to any such structure. Okay, the magnitude of repulsion between different types of electron pairs will be lone pair will be more, in between lone pair and bond pair, least will be the bond pair magnitude of repulsion. If the lone pair electrons are there, what do you mean by lone pair? Means lone pair is nothing but which is not involved in the bonding. So it will be freely in the space. What it will do, since it is negatively charged, it will repel from one another. If it is that electrons is involved in the bonding, it will be in such recognized space. It cannot repel from another electron. So the repulsion magnitude will be more in lone pair, and lone pair bond pair will be medium, bond pair will be least. The shapes of the molecules depends on the number and types of pairs of electrons. Whatever the shape we are going to represent or we are going to discuss about the molecule, it will be depend on number and types of electron. Types of electron means it may be lone pair of electrons or bond pair of electrons. It will depend on the type and number. Number of bond pair or lone pair will also make some difference in the shape of a molecule. The shapes of a molecule containing only bond pair of electrons and those containing both bond pair of electrons and lone pair of electrons are shown in the table. Whatever shape or whatever the molecule is containing bond pair and only lone pair, this will be seen in the coming table. Next, molecules with only bond pair of electrons have regular geometry and those with lone pair of electrons have distorted or irregular geometry. Means, which I told you now, what are lone pair of electrons and what are bond pair of electrons. If only electrons having bond pair of electrons, see in this only, this will be having just bond pair of electrons, so no repulsion between in that, so that geometry is confined. If lone pair is present, or see this one also, here one lone pair is present, due to that lone pair will repel and it will distort the geometry of the molecule. Shapes of molecules containing bond pairs only or bond pairs and lone pairs. Okay, shapes of molecules containing bond pairs only. If you want to see the shape, bond pairs only it will contain, or bond pairs and lone pairs also it may contain. Next one, see here, this is geometry of covalent molecules. Here shape or geometry will be seen. Here what they are telling, total number of electron pairs, that is 2 electron pairs are present means, see this is linear shape, geometry will be linear and bond pair will be 2, lone pair will be 0, that will be called as AB2. See here example, carbon dioxide, bond pairs are 2 bond pairs are present, no lone pairs only, that's why it is linear. Here also beryllium, no lone pairs only present in this. Here 3 number of electron pairs are present, 3 also bond paired, no lone pair. Here we have to recognize the central atom, there it is present or not the lone pairs, that we have to recognize. See here BF3, boron is only having 3 valency, 3 valency is also already satisfied, that's why no lone pair. This is the geometry, triangular, planar. Here another 2 bond pair, 1 lone pair means, see here SO2 means S is having sulfur 1, 2, 3, 4. That is how the 4 electron pairs have not been completely bonded. 1 lone pair is present. That's why it has been bent. This lone pair will show some repulsion. Here 4 electron bonds are there, electron pairs are there. Within that 4 bond pair, 0 lone pair. So carbon, that is CH4, methane is the best example. All the valency of carbon has been, electrons has been satisfied. So it is showing tetrahedral shape, that is AB4. See here, it may be 3 bond pair, it may be 1 lone pair, that time trigonal pyramidal, that is NH3, 1 lone pair is present, ammonia, NF3, it will show some repulsion. Here 2 bond pair, 2 lone pair, AB2L2 means 2 bond pair is there, here 2 lone pair is there, it will show bent structure. Next one, trigonal bipyramidal. that is 5 pairs are there. Within that 5 bond pair, 0 lone pair. It will show trigonal bipyramidal PCl5. Phosphorus is having 5 valency. It has been satisfied with all the chlorine atoms. That's why trigonal bipyramidal. If 4 bond pair, 1 lone pair, AB4L, it will be SF4. Due to this lone pair, it will show tetrahedral shape. Due to this lone pair, it will be distorted and it shows the seesaw shape. SF4. Next one, AB3L2, that is 3 bond pair, 2 lone pair. It will be T-shaped. 2 lone pair are present. Okay, ClF3. Chlorine usually 5 will be present. And here AB2L2, 2 bond pair, 3 lone pair. It is linear because all the side equal number of repulsion is showing here. See, here one side, here another repulsion, here another repulsion. Due to all the side repulsion is same, that's why this XeF2 will show in a linear pattern. And I3 minus Br3 minus, it will all show in a linear pattern. When the repulsion is also equal from all the directions, it will become linear. Next one, 6 electron pairs are there. Within that 6 bond pair, 0 lone pair. That time octahedral. SF6, no lone pair only present here. That's why octahedral. If 5 bond pair, 1 lone pair, AB5L, that will be square bipyramidal because 1 lone pair will be present. Some repulsion will be present. Here 4 bond pair, 2 lone pair means square planar. Here also see equal repulsion is showing. That's why it will show square planar. The 2 will be the equal repulsion. So in between the square planar will be formed. That is XeF4. Okay, this is about the geometry of covalent molecule. Covalent molecule means you know covalent bond will be present. The sharing of electrons will be present. That is how the repulsion and attraction will be seen. Next is valence bond theory. You know about valency, valence electrons. Some bond should form in between that. How it will be formed? There is some attractive forces, there is some repulsive forces. In what context attractive force will be seen? In what context repulsive force will be seen? These are the things we have to first understand. So, 2 hydrogen atoms A and B approaching each other having nuclei Na and Nb and electrons present in them are Ea and Eb. 2 hydrogen atom, it is having nuclei Na, Nb and electrons Ea and Eb because hydrogen is having only 1 electron. When 2 atoms are at a large distance from each other, there is no interaction between them. This is H, this is another H means no interaction because large distance is present. As these atoms approach each other, the new attractive and repulsive forces begin to operate. Little bit coming each other means there is repulsive force also, there is attractive force also. Attractive forces arise between, when the attractive force will arise, nucleus of one atom and its own electron, Na and Ea will be there. This is nuclei, this is one electron. Here attractive force will be there and nucleus of one atom and electron of another atom. From here to here also it will be present. Here one nuclei, this is Na, this is Ea, this is Nb, this is Eb. And similarly repulsive forces arises between electrons of 2 atoms like Ea and Eb. There is no attraction, only repulsion. Nuclei of 2 atoms Na and Nb. There is also no attraction, only repulsion is present. Attractive forces tend to bring the 2 atoms close to each other, whereas repulsive forces tend to push them apart. Attractive forces, what it will do? It will, 2 atoms means it will bring towards each other. But repulsive forces, it will tend to push or pull them from apart. Okay, see here, this is old forces, this is new forces. This is attractive force what they are showing, this is repulsive force. Okay, it is the 2 molecules will be bringing apart from each other. See here, positive sign means it is going some other side, it is moving some other side. It is also moving some distance apart, but here it is bringing near to one another. That is called attractive force and repulsive force. Next one, experimentally it has been found that magnitude of new attractive force is more than a new repulsive force. Yes, new attractive force is more than a new repulsive force. As a result, 2 atoms approach each other and potential energy decreases. Ultimately, a stage is reached where the net force of attraction balances the force of repulsion and the system acquires minimum energy. At this stage, two hydrogen atoms are said to be bonded together to form a stable molecule at bond length of 74 picometer. At some stage, what will happen? Repulsive force will be little bit decreased and attractive force will be enhanced. That time it will form a bond having length 74 picometer with minimum energy. Okay, that time potential energy will be decreased. Since the energy gets released when the bond is formed between two hydrogen atoms, the hydrogen molecule is more stable. Why it will acquire to become a stable molecule? And the energy so released is called bond enthalpy. During the bond formation, the energy will be released. That energy will be called as bond enthalpy. Enthalpy is nothing but energy, which is corresponding to minimum the curve depicting in figure below. Conversely, 435 kilojoule of energy is required to disassociate 1 mole of hydrogen molecule. See here, overall bond length is 74. This is internuclear distance. This is energy. Energy is getting decreased. This is distance of separation. This is H2 molecule has present already. It is getting separated and the bond energy will be more here and the bond energy will be less when it has been already separated. That is about 435.8 kilojoule per mole. Next is orbital overlap concept. What is orbital overlap concept means? One orbital will get overlapped by another orbital to get a more strength between the bonds. What is that concept? How it will be the sp orbitals will form. A covalent bond is formed due to the overlapping of atomic orbitals of the two combining atoms, each of them containing one unpaired electron. The new orbital formed due to the overlapping of two atomic orbitals is called a bond orbital, which is common to the both of the atoms. Means a covalent bond formed due to the overlapping of atomic orbitals. Overlapping means if it is present one, another bond will be overlap or like this. Okay, that overlapping will be present. A new orbital formed due to the overlapping of two atomic orbitals due to the bond. Okay, the shared pair of electrons occupy a bond orbital. Whatever the shared pair, the electrons will be paired or shared, right? That will be participating in the bond orbital. The strength of a bond depends on the extent of overlapping of the atomic orbitals. Greater the degree of overlapping, stronger will be the bond. Here the bond strength will be more due to the overlapping. The two electrons involved in bond formation must have opposite sign. If it is positive, here negative should be there. Okay. Two covalent bond is directional in nature and lies in the direction of maximum overlapping atomic orbitals. The covalent bond is which is forming, it should be directional in nature and lies direction of the maximum overlapping. It should be arranged itself to get a maximum overlap. When it is getting maximum overlap, what will happen? The bond will get much stronger. If you compare the sigma bond and pi bond, sigma bond is more stronger than pi bond because it is actually overlapping. More overlap will be seen. Okay, you will see next with some of the examples. See here, when orbitals of two atoms come closer to form a bond, their overlap may be positive, negative or zero depending upon the sign. Direction of orientation and amplitude of orbital wave function in space as shown below. See, any phase can be overlap. It may be positive, it may be negative or a zero also. For that reason they are showing here. It may be positive or it may be positive negative. Here also these two are both p orbitals. You know p orbitals will be in a dumbbell shaped. Correct? S orbital will be spherical shape. Here both are p orbitals with the same positive sign. Here both are p orbitals with the opposite sign. Here 1p, 1s with same sign. Here 1p, 1s with opposite sign. Here also see, these are all positive. P and p. This is also p and p with opposite. Here maximum overlapping is showing. Here also with opposite sign maximum overlapping is showing. Next, orbitals forming bonds should have the same sign and orientation in space is called positive overlap. Various overlap of s and p orbitals depicted in a showing figure, while the bonds showing negative overlaps, that is when the orbitals forming bonds have opposite phases, is called negative overlap or different overlaps will be seen. See here, this is positive and this is also showing positive side, while the zero overlap which has orbitals approaching in wrong directions, this is no overlap only seen here, zero overlapping can you Observe here. So in the orbital overlap theory, there are two types of covalent bond is present depending upon the manner in which the overlap will takes place. Okay. There are two types of covalent bond, that is sigma bond and pi bond, or you can call it as sigma covalent bond or pi covalent bond. It will be based on the overlapping manner. So first we'll see what is sigma bond. A covalent bond formed when two half-filled atomic orbitals overlap end to end along their axis is called a sigma bond. This results in the maximum overlapping, hence it is strong. How? We'll see now. See here, hydrogen means 1s1, another hydrogen means 1s1, electronic configuration will be present, and it will be formed by the end to end, and it is having the maximum overlap. That's why this sigma bond is very much strong. This is SS overlap. We know S orbital will be spherical in shape, and we can consider as S and P orbitals also. See here, HF means both the elements having a single electron, that is unpaired electron in its valence shell. This is S orbital, this is P orbital. At the end, it will form SP overlap. Here also PP overlap, that is dumbbell shape. Both are dumbbell shape. So overlap will be at the end. See here, overlap is maximum. This is also sigma bond. Then what is pi bond? A covalent bond will form when two half-filled p orbitals overlap sideways or laterally. Is called pi bond. Pi bond is weaker than sigma bond because the extent of overlap is less. That's why pi bond is little bit weaker comparative to sigma bond. See the example, O2 molecule. The electronic configuration, everything has been written. And this one will form a sigma bond because end to end overlap will be more. But this p orbital completely takes place by sideways, that is laterally overlap. That's why it will form pi bond. This will form sigma bond. See here, in N2 molecule, one sigma bond will be present, two pi bonds will be present. Other two bonds will be laterally formed. That's why. Next one, the difference between sigma bond and pi bond. Okay, you might get confused what is sigma and what is pi bond after all reading or after all getting to know. So, better you know the difference between sigma bond and pi bond. What is sigma bond? It may be formed by axial overlap of SS orbital or SP orbital or PP orbital. You have seen the examples now. But in the context of pi bond, it should be laterally overlap in only P and p orbitals, not with another orbitals. And sigma bond is more stronger than pi bond because the extent of overlapping is more. But pi bond is weaker than sigma bond because the extent of overlapping is less. Only one bond, sigma bond between two atoms. Only one you can see, but two or more pi bonds you can observe between two atoms. And sigma bond can be rotated along the bond axis. Along the bond axis it can be rotated. But the pi bond cannot be rotated relative to the atoms along the bond axis. It cannot be rotated, but it can be rotated. And this introduction part or the concept of sigma bond, pi bond, these are the important topics to understand the organic chemistry well. So, in the next session involving all the orbitals, the hybridization will take place. About that we will study the hybridization. In that types, various kinds are there. sp3 hybridization, sp2 hybridization, and hybridization involving s, p and d orbital also you will study in the next session. So, I hope you have understood completely what I have taught today. We'll meet in the next session. Thank you.